thank you everyone for coming over here. As you already can see, this is the last chapter of the associate training guide, which we are following in terms of its most of the contents as well as the structure in terms of chapter. So let's go to the. I just want to cover this so that you guys exactly know which document we are referring to in most of the lectures. But these lectures will also be available. I think there are some Sean and some others which are working on get those lectures available. Is my microphone working?
It's a little far away from here. It's a little bit quiet like that.
Yes. Okay. So let's go to the slide. So how many of you guys are aware of? I mean, I'm not talking about in specific to object storage. In general, what does anyone has any idea what exactly object storage is? In general, just okay. Get the mic as well. Okay.
You're just leaving your mic down. Yes. Oh, I see. All right.
It just stores unstructured data, a lot of stuff.
Okay, that's good. Anyone else wants to chime in? What exactly object storage? I know we always probably most of us know what exactly storage is, and if you don't know, then you can still raise a hand and ask those questions. Somebody have a hand up?
I'm using the body storage. So I don't know why I sure what's going to do in the body storage.
That's a good question. We will cover that. I think we also have some questions.
Well, it uses HTTP transport out of the service. It's coming from net.
Yeah, that is one way to define it. That the main characteristic of object storage. That's a good way to.
It's the way the storage say what it is not. I guess it's not hostile. The different one is find a file, put it in a certain block, and then you want to retrieve it. That's that. An object, you create an object, and then you go in and use HTTP. What is essentially I'm trying to say what is not one type of traditional storage.
So in general, when we talk about storage, we are like, if you for the time being just forget like all these fancy buzzwords like okay, it's a volume storage or block storage or object storage. Just storage, if you just think about that. Obviously, you are talking about some kind of a disk where data is going to be residing on a permanent disk. Otherwise, you can just use RAM disk as a memory-based storage where disk will not be but in general, when we are talking about storage, we are talking about some kind of a disk. And the moment we bring in the disk, then the question comes up: how we will store that data on that disk? What kind of structure we are maintaining when we are writing all that bits out from our application? What exactly that bits will be residing in what form? How those are going to be managed? How those are going to be accessed? All these kind of ideas which you guys are explaining a while ago. That okay, you can access them like directly by opening the file and closing the file in a more kind of a traditional method. In a file system access way. You can access them in an HTTP, or you can access them in a more kind of a like a typical blocks like a file-based storage where you have a special protocol which is giving you the access to the blocks available on the storage. So there are so many different ways. So from that perspective, you can imagine that we are talking about the bits or the bytes which are written on the disk and how those are being accessed. That's a very like a generic definition of delineating between what is this type of storage versus what is that type of storage. Now coming back to the object storage, when we talk about object storage, we are talking about a very specific type of storage, access or storage. These are some of the characteristics which basically defines object storage or something which is not an object storage. One of them is that you basically organize data in a more kind of a hierarchical way. So you have some kind of a scheme which defines some kind of a relationship, and that gives you the ability to access that data in a much more faster and seamless. So that's one way to define them. So when we are talking about the storage, we are talking about how we are accessing that data. Like, for example, if we are storing that in a certain kind of structured method, in a structured way, where we have a parent-child relationship, and you have stored the data in a kind of a small bits and pieces, and those bits and pieces have maintained some relationship, then we are basically talking about objects. Object storage. Anyone have any idea how much data is stored in Amazon? Like Amazon has S3 at this point. How much data they have stored on Amazon storage at this point? A wide guess or something?
A couple of exabytes. Exabytes.
Terabytes?
Exabytes.
Exabytes. Okay.
I want to share this screen because right now we are sharing
So this
the camera.
is the slide
Those
which you can
who
see
are
over here, that how much data we're talking
they
about.
cannot see that.
This is like a 2 terabyte,
So I'm not sure.
2 trillion
Able
bytes actually, objects, 2 trillion objects, not bytes. 2 trillion objects. These bytes can be much higher than that. I mean, you're not classifying at the byte level or at the kilobyte, megabyte, at that. We're just talking about the objects now. Object can be an 8K object, or it can be. Generally, the objects are stored at the place where how your disk's handle can fetch that data in one go. So if your disk can pick up the data in like 8 kilobyte chunks, when you store that data in chunks, how much data you can fetch in one go, that's what typically objects data is stored. So when we're talking about objects, we're talking about that kind of a chunk which you can, because that gives you the boost of the ability. Let's imagine if you have a much bigger chunk, and if you need to fetch 2 chunks, then obviously there is a price you need to pay. So you need to figure out where is one chunk of that. You have a big file and you split into such a way that you need to, every time you pick them up, you need to do multiple reads in a sequential way. First, then second read, then third read, then fourth read. If you're doing it that way, then these becomes really pricey when you are doing it again and again and again. But if you are not doing it again and again, let's say if you define your chunk in such a way that in one go when the data is requested, the whole file is spread out in such a way that you say, I read request, and you get one chunk from here, one chunk from here, one chunk from here, and all of them are read at once. Then that's where you get a lot of boost. I mean, it becomes really fast. So these are the read requests as well, like 1.1 million. And these numbers are, by the way, in 2013. And we are like now 2015. So you can imagine. And this curve is like, it's kind of a hockey stick. It's going up like no one has ever seen that kind of a. And this is just an S3 at Amazon. So the reason I'm bringing this up is that that's where this much data, if you are storing it in object store, this is the capability of object storage. And if the OpenStack is designed along the same lines, just very similar to what the Amazon S3 is. So even if it is so closer that even the APIs which are available for S3, you can just use those same APIs. Imagine your application is written for Amazon S3, and you just happen to have a OpenStack object Swift, which is called Swift. That's what is deployed. Then you can just point your application over here, and now you can start using same APIs against the Swift. So now, what I'm trying to make over here is that that's much it is. Any question or comments on this or previous slide?
Where's the largest in case of
Something is
those numbers are, I'm not aware of that. Those numbers are not officially published yet. Rackspace probably has a very big deployment. You can imagine those where the public data is stored. That's where the bigger deployments are. Obviously, at the enterprise level, it may not match even this number, but where most of the service providers which are providing the services to the masses, whether those are in the consumer domain or those are in the managed services or enterprise domain. That's where probably much bigger you will see. So the capability is there, but usage may not be there in a very small or even a large medium enterprise. But a very huge enterprise where huge data processing needs, the storage needs are there, like some online store or something like that. That's where you can really leverage this. So, anyone has any idea what are other large carriers or large object storage providers? Feel free to share.
It has a large distributed object storage. I think house is in house. The last numbers that I heard were probably 300 terabytes. You have a large long-range multiple data center. So actually, I had a follow-up question on that because I'm just familiar with the examples, and in the previous slide you had mentioned that the object storage requires less metadata than the traditional block storage or whatever. Can you explain what you mean by that?
So, okay, so that's it on this. Still, yeah, any issue?
yeah.
Actually,
Yeah.
I think that's the question of another example is Google Cloud Storage has it, and Facebook has their own type of storage system where you have a lot of data.
Right. Google is one of the biggest keeper as well.
Somehow we have to achieve that what you are seeing in your laptop, we are seeing the same here. Because when we are sharing, we just sharing the PowerPoint presentation, and when you are moving the slides, they are.
Oh, it's showing the one which is on my screen?
Yes.
Let me see how.
So sorry about that technical.
I don't know how to turn off that. Anyone knows how to turn off that? There's a when you present it on a projector, there is another view which shows up on the
toggle it, percentage is percentage, you know, toggle that.
I'm still showing on my screen.
What's more likely is you're sharing the wrong
I'm
screen.
talking about this view, which I don't want to see. I want to disable that on my laptop.
You don't need, you shouldn't need to disable it.
No, you're sharing it.
Yeah, but you're probably sharing the wrong screen.
You know, in this interview, it puts, he has one screen and it goes out to the other monitor on with a different, with a full screen.
Right, but you need to be sharing the screen that's going out versus the one he's looking at.
Now it's flipped. Now it's flipped.
Experience. AP is not your friend.
Unless I keep it this way.
Yeah.
So far we were talking about the string of now.
It works.
Right. So far we're talking about the object storage in general, and now getting back to the Swift, how the Swift is storing all this data. So again, the Swift is the open source software which is creating redundant, scalable storage clusters. And how it is storing all that data is that it is basically maintaining a structure of kind of a map where it not only maintains the ID and the actual data in a kind of a chunk, in the form of a chunk, but it also maintains its metadata as well. And what metadata does is that it basically provides a kind of indexing to actual data. That's the way, I mean, that's the kind of crux of this whole object, Swift storage, storage. And there are some other benefits as well because the data is stored on multiple nodes. At least probably the typical deployment consists of 3 nodes. So you have it stored on at least 3, and basically 3 of those nodes you have data is replicated as well. And it's kind of a self-healing as well, that in case any failure happens, and if you remove that disk and put the new one, the system will automatically know, and it basically makes the catch-up job pretty good, and it basically re-replicate the data once the node is re-adding back. It's a kind of a very similar concept if you have a RAID disk in your server, and one disk is failing, and if you remove it and put it back the new one. It's a very similar concept, but this is happening all in software. Not like a RAID controller, it's just typically going more or less. So, plus it is running on, now you have the capability to run it on a commodity hardware. You're not buying any expensive storage, you are kind of buying a very cheap servers and running the software on that kind of so you have the capability to scale almost like infinitely, because there is no concept of a cluster where there are some limitations. Is there any question over there? Any question? No? So you have a question.
Let's say you have a really
you big file, big conference, and you use an object storage. The question is, how do you really assure that it can go out in one shot? Where it should go out in one shot?
So what happens is that Swift introduced the concept of container, and the container is, so there are 2 aspects. One is the containerization of the actual data. That's basically a kind of a definition, a meta definition, which tells that okay, this whole set of this whole file is just one file. That's what your containerization is telling. But the other part of that is that, which is the job of the Swift, is what you basically tell whoever is storing that data that okay, break this file into let's say 8K chunks. So within that container, that particular file, which is a very large scale file, is basically broken down into those small pieces based on whatever size you are telling, assuming that you know exactly as an engineer or whoever is the administrator. Basically, you might be exposing that number, or you may not be, or just hiding it, and your administrator will be just maintaining that number. That if it's an 8K chunk, then that number is basically is the one which is your unity to store that data and the lowest. That's the way it is.
So that 8K is the size of one object.
8K, it depends. I mean, most of the, I mean, there are a lot of disks which give you 8K access in one. It depends on what kind of I/O you have on your disk. Typically, it is 8K chunk, but you can have 16K chunk or 10K chunk.
So if I'm putting in that to giving file and one chunk size is 8. So how many objects I have?
You can have as many objects, but what will happen is that if it depends on how many parallel disks you have. So if you have a very like let's say a gigabyte of size of file, and you are breaking it down into let's say 8K chunks, you have a lot of chunks, right? So you can have multiple IOs like 16, 17, 20, or maybe a couple of hundred IOs as well in one go, which will store one part of that file and then the second part of that file. So some of the chunks will be queued. But if you have a very large, if your use case is there that you always have large files, then you probably, which means that you will have a larger amount of disk, which automatically means that you can have a much parallel IO capabilities are also available. So if you have that much bigger of a file, you would rather prefer to have that many parallel 8K or 16K chunks are available to store that. So you are kind of it's like imagine it's like a kind of a freeway, and you are opening multiple free lanes. So it depends what is your use case. If you think that you will always have a large scale file, then you will have multiple lanes in that freeway. If you think that your use case is that you don't have that many big files, your files are typically, let's say, 8K chunks of 16 8K chunks, then you probably will open 16 lanes. So that many of the disks you will have. So that's a kind of a scheme which typically is followed. But then there is some kind of a smart, you can also introduce some smartness as well that, okay, for this kind of a data, this type of my object, this section of my storage or within the like a tenant type definition which OpenStack provides, you can define different subset of the object storage as well. Then for large scale databases, I will use for large scale storage, I will always use this piece of my storage which is quite expensive, and I'll charge more money because those guys are using a lot more. And these guys which are just storing a very small file, which are I can use it on a very cheap disk, and I don't have to maintain a large parallel bus for that. So I can offer that in a different type of storage section of the storage. So these things are like they are not any different from like what OpenStack provides you, the different level of services, but that's how you can do the Swift gives you the capability. I mean together with OpenStack. So now you have a kind of a tenant or a project definition and service definition. Bundled along with yours. Any other question anyone has?
So I wanted to know, if there's the data is stored, the one node goes down and says the data is reconstructed from another different node. So is node at disk or what is the node mean?
So in this case, node you will have when you deploy the object storage, you will typically deploy 3 nodes. And Disks could be as many as you want within one node. Up to you how many disks. That is giving you a different level of protection of your data. You have, let's say, 2 disks and you are doing a RAID 10 mirroring, like a mirroring of at a disk level HA you are providing. But this is completely when I'm talking about in terms of Swift or in terms of object storage, I'm not talking about disks at all. I'm talking about at the software level when I'm talking about the different software cluster nodes which are running on a different piece of hardware, and those itself at a higher level giving you a parallelization and
They're replicated.
I'm new to this stuff. My understanding is on these very large storage systems that are using a key and it's a object or whatever you want to call it, the key is what allows you to do the events and spread over several disks. Is that correct? And the key itself is the solution.
that's called metadata. That is called
It points to the metadata or how
That's it varies on depending on like if you're using EMC versus Swift. There are so many different variations and how they are using key, whether the key itself is replicated or there is one master control node and there are all other slave nodes. There are different variations in that from the implementation. But metadata is very important. If you use metadata, then you have to be problem.
and the key ties that to the keys. How you tie them.
Yeah, metadata is more kind of a, if you look at from the pure database perspective, it is kind of an index of actual data. So it's that's kind of a relationship, but it is much more than that. Which node it is stored, multi-cluster, and where exactly on that node.
It's kind of analogous to a hash map.
Right. So these are some of the benefits as well, which are inherent as a part of the Swift. Like for example, you have kind of a very cheap hardware because it's a 3x application. So obviously you get higher redundancy as well, bigger redundancy as well. You don't have to rely on the RAID on the disk because it's an additional benefit if you have RAID, but you don't have to because your data is automatically replicated. In case any failure happens, it's going to be seen as on the user end. So you don't have to worry about it. And as I have already mentioned that the APIs are almost identical to S3. So if you are using SP type deployment, like your application is written in such a way that you can use SP APIs, then you don't have to change them. And all of the benefits like the access role-based access controls are also part of Swift because they are part of the OpenStack authentication and authorization scheme. So from the tokenization perspective and access control perspective, whatever Keystone is providing you, you can be leveraging all those access controls. It won't allow you to access it if you don't have right permissions or access. Whether you are creating an object or you are this time.
What about subscription? Do you have subscription? For example, we have
so you will give the you will create different projects. In the OpenStack is called project. You will have one large object storage deployment, but you will control them which tenant can access or whatever the object they will create. Only those objects they will be able to use. That it's not like you are slicing the system. It's more like what you have created. That's what you access. It's that kind of thing.
So they are saying So what you're saying is the tenant doesn't have any hierarchy.
There is no hierarchy in tenant. Like how? What do you mean by tenant hierarchy?
I mean, doesn't matter now. The project, I create a tenant of the tenant. So that means you have to go to one tenant in order to connect.
Yeah, in OpenStack, when you're talking about tenants, generally you're talking about you're not talking about tenant in this. You're talking about if there is one tenant, then he is by itself always whatever the rights, access, and controls are, and there is another tenant, even if it is under the other tenant, you don't want to. If there is no concept of inheriting all the parent access controls under another tenant. Concept is that it means another parent that you basically create a separate. You can share the keys and things like access like token, not the token, the keys basically, or the policies as well between multiple tenants, but not that you cannot inherit. That kind of a relationship is not there.
So that's a friend.
It's more like a friend. There's no hierarchy. And if you want to take the snapshot, obviously you will be taking those snapshots on the you will be taking that on the block storage. There are a lot of vendors like NetApp, Extend, Multiplier, all the new ones keep coming as well, which are using this technology as well. They are providing the APIs. They are kind of from the so from the top perspective, you are running the Swift or largest storage software, but then from the actual disk management perspective, at the low level, instead of using a commodity hardware, you probably using some robust technology for the actual storage, like that or probably EMC, probably maybe also be there. It depends on those kind of use cases where your data is so much critical that you want not only want to leverage what the Swift is providing, but you also want to make sure that whatever the data you are storing on the disk, there is additional layer of storage functionality provided by these well-known and protection of the data. So these are some of the commands which are available through the CLI. The GUI part is very easy to, very simple, very. I mean, there are not that many commands. I think when you look at these commands, then you probably have a pretty good idea of what exactly these commands are. From the UI, obviously, you can just like create. If you really want to appreciate what exactly under the hood is happening, then you can look at these commands, which that I mean, if you wanted to upload some object, you basically would provide the Swift upload. This is the most simplest form of command which I put it on the slide, but there are other attributes which are coming out in the next slide, which will tell you that how you can create, or there are several different parameters you can use for accessing that. So as you can see over here, for example, when you are doing the list, it will basically asking you to provide token and URL where you want it. This is more like a kind of API REST-based access to the object storage. And similarly, if you just want to see the stats, then you should this command. So let's go to the actual running system and see how it will look like. So this is what I have logged in. This is the OpenStack user release.
Can you share this window?
Oh. Is that showing up now?
Yeah.
This is one of the files which is created, so that's showing up now? So this is the Juno release, and as you can see under this project, this is the admin project. You can see objects stored over there, and that's where basically you know, this container. How you will access that? There are so this is what is showing up in the registry. And also providing the S3 API services as well. So there's not only running this script as an object storage, it is also providing an S3 service to access. And access and security. Also the API access. This is the access to the object storage, and if you are trying to access to S3 APIs, then this is the interface you What I'm going to be doing is that I'm going to be using the CLI to create the object and store the object and show you how the data will show. Right now the container is empty, so obviously we need to create a container as well as we are going to store some object. So one way to do that is through the GUI. But let's do a more interesting way, which is basically through the command line. The CLI, it's, I mean, the whole OpenStack, most of the OpenStack is in Python, but the command line, the CLI is a more, it's more like a kind of a shell command where you are issuing different options. But you can, yeah, it's not exactly a Python. So let's see. If I do the source, then it basically sets all my login ID and passwords so that I don't have to enter them. And now if I'll do Swift list, I can show you what exactly is in the object stream. At this point, there is nothing. But if I try to, let's look at the file. If we have some file over here, let's put this file on a start file to the object storage. So upload. So this is the the command which was on my slide, Swift upload. So I'm using this command to upload this object. So why there are two of them, Anaconda KS or let's call it Anaconda. Okay, so the first parameter is the container, and the second parameter is the actual object. So if you wanted to see what exactly it is, you can issue the account command and so this is what it is showing is basically when you upload, what are the different options you have available. You can provide the segment size, and if it is exactly identical, you still wanted to upload that, then it is showing you that you can skip, you can set this flag. And in the very last, I mean, all these other options are, all these other parameters are optional. If you wanted to use them, then you exactly will know why you are going to use it. These are two parameters which are required. Which container you wanted to upload this object, and what exactly is the object which you are trying to. Whether it's a file, it's a directory, or it's a very large, some other type of object or set of objects, you can provide variety of them. But what you are providing over here is basically the mechanism to upload them. And in addition to that, if you look at the slides, there are a few other things which are also available. Like for example, who is the user? Let's say you have the particular user and the specific password or a specific tenant of the project in the OpenStack that is called. You can provide even all these other attributes as well. Like this is the project, this is the user. Like for example, if I'm a user, some endpoint user, then I will be providing all of these things, and then I'll be uploading my objects. And similarly, I'll be retrieving the gem as well. So these are some other attributes which are also available. Let's go back to the command line. And let's try to upload that. Obviously, it doesn't exist where it is. So now it's uploaded. So now if I do this Swift list, you should see that. So it is showing the container, and it is showing the object which is inside the container. So now let's go to the GUI and see what exactly it will look like. So if you go on the GUI, then you will see the container, and if we go within that container, then it is showing which object we are talking about. So if you have multiple objects, and it's storing in a 1K byte size, segment size. We can do all these operations through GUI as well. But if you are using it, and if you want to make it public, obviously you will change the permission either from here or from the GUI.
Your OpenStack Swift is for this example.
In this example, there is a VM running basically. But in reality, you will not run that.
But when you actually put it in the cloud, you will see all copies of the object.
No, not all the copies, no. You will not see all the copies, you will only see one, because that's what Swift is hiding, what exactly it is doing. It is not going to tell you what it is.
So where do you get the actual view?
There are some additional commands too that you can see those. So those commands are available, which can tell you how the objects are distributed.
And is there a way to expose the metadata?
No. Because then what will happen is that imagine someone is trying to mess around with that, an object Swift will completely get confused.
My question is only read-only way, so that for example, I'm bringing up a use case where storing different sizes of files, different types of objects, for reporting analytics. I have
the question you should ask is that why you need that, like that kind of a granularity, why you should do it. I mean, that's the question because the whole idea of Swift is to completely hide and make it so. The idea is not to expose that because if you have that exposed, then you are kind of killing the whole the reason of Swift, which is basically that you don't want to worry about where that data is stored. And if failure happens, there is a way to recover that, or you don't even have, there is no even outage from that perspective. So from the end user perspective, there is no reason to expose that or need to know that. Only thing you care about is that whether that server or that disk is up or is it running or it's not running. That's it. And that even the user itself provides the monitoring mechanism as well. So if failure is happening, you will have the ability to monitor or get that report. So I mean that's why you need to first understand why you need to expose that. But if you're just talking about access, then there's no reason to do that. Why would you access? If you just wanted to see what is, I mean, if Swift is providing you the way to monitor that data, then that is sufficient. But if there is some other use case, then obviously that needs to be understood.
But I mean, we have a question over here.
Containers are in the hierarchy under accounts, right?
Containers are under project, under project or tenant. They have access controls, you can access them, but they are not under accounts. You have the permission that who can, the permissions are just like any other resource under OpenStack. Who can access which VM? Who can access certain type of ports? Things like that. I mean, we have those definitions already, like at the VM level, the network level, who can create networks, who cannot create. So all these definitions already exist, right? So OpenStack is using the same structure to give to control the access to those objects which you are.
So it goes from tenant to containers to object, not tenant to account.
Hierarchically, you can only look at from this perspective that you have a tenant or the project, then you have container, and then you have object. That's it. But who can access that? That's a kind of a different matrix. Admin can access all of them, but other users they will have. It's up to you. You will define that who can access it. All other users, if you want to give them access to every object, then you will not have to use public. So that's what public does.
How do you do the erasure of the sensitive data? If you are on a local disk, I delete it, of course, it's still there. It's on the disk, then I can have some program to actually erase, overwrite. If it's on the object storage, I don't even know where it is. I remove it and
no, it will be deleted. It will be deleted. You will not. I think your concern is more that okay, when will it be deleted? How do I make sure that it is deleted? So there. I mean, I think it's if you look at the Swift, if you look at the idea is not to expose that, but at the same time, when you delete something, it first marks for delete and eventually it gets deleted.
Eventually.
Now, when that gets deleted, that maybe for that kind of use case, you may have to consider some other type of storage. Maybe object storage may not be useful. It's there are some.
So right now, the Swift storage is not considered any of those.
It might. I mean, if there are some requirements, there's still some discussion going on from the securities, OpenStack security perspective. So some of those things are being discussed, how to ensure those requirements. So probably under that category, they probably will bring that up.
I had a question around different kind of storages what we use, underlying form storages. So like if I'm installing HP, let's say pre-bar, I might use virtual storage array of HP, and I'll probably do a Swift deployment on that. So is there a plan for a common API? Like, it goes like how we have in center? Is there some plan for common API for different storage vendors? So if I use a NetApp or a EMC or any other different kind of one storage,
So I think your question is very valid, and there are different vendors, they have started considering that. But it's going to be very much like for example, Neutron, a network piece in the OpenStack movie. If you look at it, at the beginning, the Neutron, like the Linux networking was very simple in the beginning. Then they start becoming more and more complicated, and then they start thinking about making more vendors, and then writing the plugins or the APIs to which, from the Neutron perspective or from the end user perspective, there should not be any difference from how you access that, but from the actual underlying technology perspective, you have different vendors coming in and they start using it. So different vendors have started considering that for the Swift as well. How many of how many of them are ready for that? I don't know. I mean, that probably may have to look on a case by case basis. That like if you are interested in EMC, then okay, how far EMC is from the object store, like full integration with the Swift.
Sure. Today I cannot go the EMC or not right away.
I don't know. I mean, I don't have the answer for that. Like from the vendor perspective, I don't know. Like since I'm only at this in this particular scenario, I'm only considering non vendor deployment where just kind of you are using a regular server, large disk, filling up the disk bay with maximum disk capacity, and then using the Swift to manage this. It's a very kind of a very simple deployment model. Versus which you are talking about is that there is some kind of a hierarchy in terms of where the Swift is running versus instead of managing the disks directly, you are managing through another layer in between, which is actually managing the disks. So it's that question that I don't have the answer right away, but if you are interested in anything specific, then I can go back and look into that and then come back to you. Yeah.
Just to confirm my takeaway on what you explained, OpenStack object interface is modeled after what Amazon did in S3.
That is correct.
The management capabilities inside S3 were never exposed. So there is nothing about management of the underlying storage infrastructure exposed via OpenStack interface. So which leads me to believe that when NetApp says we provide OpenStack enabled storage, or AMC says the same thing, or IBM and so on and so forth, they would provide their own storage organization tools to configure the underlying infrastructure on the top of which OpenStack will support the storage model, which is S3-like.
So I think what you are saying is, from the end user perspective, you are correct.
Actually, some vendors are going beyond that. What they're actually doing is on their stack, they are providing the Cinder or the Swift APIs so you can talk directly to it, and they're handling it. They're not loading a normal OpenStack on top of it. That's plugging it in as an OpenStack component.
So yeah, and I'll just add, I was exactly coming to the same point which you just highlighted. That like if you take the example of SAP, the ink tank software SAP, which is also kind of storage software, right? The only difference is that it is not coming from the storage company; it's kind of running on a regular hardware, like a kind of a commodity hardware. But think about that from the other storage vendors as well. You can kind of relate to that. But what they are doing it is that they are integrating with the Glance or with the Swift or the other capabilities on the OpenStack side, and they are providing a layer which basically, from the user perspective, you are still talking the S3 or Swift APIs, but underneath that is basically handling through that particular vendor, whether it's a SAP or any other like EMC or any other vendor.
And SAP comes bundled in
into the OpenStack distribution?
No, it is not.
So what, in this particular demo, what is underneath?
So in this demo, I'm just using a simple disks. I'm not even running SAM. So it's only exposing the from the API perspective. It is only exposing the Swift, but there is no storage there. It's just using a regular disk. So that's the simplest possible storage deployment. Which is basically you are using a regular disk. Only difference is that you can store objects. Split the file and store it in the form of chunks. That's the only difference. So let's see. So if I want to delete that, so to maintain the hierarchy, you can basically let's look at the few other commands. There is another command which basically will tell you how much it is being used, and this is also giving you some details regarding your object, which is stored. And this one is showing you yes, it's not capabilities. So this one is showing you what exactly is allowed or what is not allowed, what is the maximum, what is the metadata count, length of your container. So let's I delete it won't allow me to delete because this object can exist in multiple containers as well. So you have to tell which container it is. Only then you can delete it.
In a large scale deployment, you have to spread out the containers.
Can we ask you to?
You just mentioned that you were trying to delete an object and you have to specify the container. So in a large scale deployment, you have millions of objects spread across multiple containers. You have to, I mean, is there a way you can specify multiple, as many containers as you want for multiple copies, or?
You can, yeah. You can specify multiple containers. You can keep going and then. Now the file is gone, so if I go to the GUI, you can see there's nothing in the container.
Yeah, in Swift only environment, we have account, container, and object. You access with URL account, container, object, and get the object. When the Swift is integrated to OpenStack, till now I cannot find where the account here is storage area of the identity.
I did not fully follow your question. Can you repeat the question?
Yeah, I mean, for the Swift only environment, we have account, container, and object.
Right.
In this environment, we don't have account. I mean, storage area.
Account is more like in this case, account is basically the access control, right? When you're talking about account container, you're talking about a separate container in your deployment. Is that what you're talking about?
No, the account is on top of container.
In terms of the hierarchy. That was one of the questions someone also asked, that in terms of the hierarchy, where you put the account. I do not look at it that way. I think that account is a kind of a separate thing, because you can, from the storage perspective, you are only storing objects in some container, and that container belongs to some project or some tenant. Who can access that is a kind of a separate set of information, and that can change as well. Your container, that hierarchy which you are talking about, that usually don't change. That is, once you store it, that stays the same. Who can access that? Some users you can remove it, add new users and things like that. That's why I think that the account or the access control should be out of this. It should not be a part of that hierarchy. And because if you have one user can have multiple container accesses, so that hierarchy doesn't fit very well.
Story area. No, I mean people with only the content you guys.
No, I mean, when you're talking about account, are you referring to the control who can access those objects, or when you're referring to accounts, are you talking about something else like? Yeah, but I mean, when you're talking about volume, then you're not talking about objects, right?
For raw storage, there's volume folder, and for page storage, there's count container.
So my question is, the user can be a member and they have access to it. So the user is basically an OpenStack user, no type of object, and it's just a lower level. Then it gives you access to everything underneath it. User might have some access to the container, but not all of them based on what the admin is giving you. Is that what you're talking about, the user, or not an account that sees everything? I mean, the user? Well, okay. Yeah, think of it this way. On the storage side, you have the containers and objects. There is no concept of users or tenants or anything like that on the storage side. All of that's permissions. It's all not quite ACL, but more similar to that concept. It's metadata of who can access things. It's not part of the hierarchy.
It's even stored separately as well.
Correct.
It's not even
stored in the same storage at all. This is separate. You have a question over here?
Let's go with the question.
So in this, in your demo, storing point, right? So is the data redundant captive by default, or is that something that we consider?
It's a feature of if you're running a Swift software and it is basically it guarantees that it is replicating. That's the job of Swift. So that fulfills
in this configuration of how you build your Swift cluster.
Yeah, but in the beginning I said that you need to have minimum 3, and you can have as many as you want. So that's how you expand you scale your redundancy. And then not only that, you also tell how many redundant copies you want to do. So if you have n number of nodes, you of course it's not going to be replicated n times. You will tell you wanted to have it 5 times, 3 times. 3 is the minimum, but you can go as many.
In order for Swift to find an object, it only uses the account rank. It doesn't use the container rank or the container rank or the account rank. All uses the object rank.
That's a hash. The ring is basically a hash.
It doesn't use the account rank or the container rank.
It uses both of them. It uses. I mean, it gets. First, that's why when I was trying to access the object in my demo, it does not know where it is because you need to tell which container it belongs to. The reason it is required is that let's say you have the copy of, let's say you have the Anaconda stored in 2 places. It probably might store at one time because if you are trying to copy the same file in 2 places. But it will only create 1 copy of that at the low level and create a kind of a reference from the second container to the first one. So that's why you need to have a container as well to get to the object.
Just here, are we fixing I store an object A under container B, and it gets replicated over to 8.1, 8.2, 8.3. I may have also copied container object A over in container 2. So that's two different objects. Each one of them is going to have their own replica.
Right, but A1, A2, and A3 are going to be accessed to that particular container which you belong to. Yeah. Right.
And if I don't need to know where A2 are.
Exactly. You don't need to do, but in terms of how the Swift will access it, it would require that piece of information, both container as well as the ring for the hash map for the
You mentioned that the creation of this object storage is separate from the access control. So later on, who is going to grant this access control? Is it the admin or is it the tenant? Because it's a type of thing.
when you create the users, whoever is the administrator, that administrator gives the access to different. So administrator will create the containers, or most likely, and then give access to different users to those containers.
No, well, when you create a container, when you create a container, you're giving it to the tenant, to the user, and the tenant.
You can I mean, you can create. You don't have to create containers. You can just create a tenant and give full access to that particular tenant to create their own containers and then create their own.
Okay, so later on, that tenant can give read or write access to
Some of those
objects, right? So would the tenant have the ability to do that, or you have to create separate container for different read and write access for different users?
So most likely in a typical deployment model, there will be a tenant operator, tenant administrator, not the administrator. That administrator will create, that will have because he's the admin of that particular tenant, he will decide and create the users and give access to those container read only or read write. Yeah. But he will not have the ability to create, let's say, he will not, there are some limit when you can, at the OpenStack level, when you create a tenant admin, you can limit quota and things like that as well. Okay. You can only use this much of a object storage, or you can limit how many containers he can create. He cannot create more than, let's say, 100 containers or something like that. All those numbers are configurable. So you can live as a SP or as the overall sysadmin, you can limit how many those org level or that project level admins can do. And then similarly, at the user level. So that's pretty much it from my today's chapter perspective. Let's look at the slide, the actual guide, if there are any further link over here. Then after that, we will have a quiz, and then whoever will answer all the questions will take what? Will get what?
Yeah.
All the questions. It's too hard to do that way. I keep it in my head.
And there is no quiz today. Okay. All right. Okay.
This quiz is just for fun. And work.
So that's it for today, and I think Ricky already announced that the next week you'll do the reboot.
The next meeting is scheduled. This meeting is scheduled for March 5th. There's happens to be 28 days in February, so it's really easy to figure it out. 1 month from today, it'll be Thursday, first Thursday of March, and are we having a hackathon?
Next, yeah.
Too. We're going to have an advanced section.
Well, okay.
We're still deciding if we're going to have an advanced section as well as this section. But the plan is to reboot, start fresh from the training from the start.
Yeah, check the Meetup site.
Yeah, keep if you have any questions, the best way to ask questions is through the Meetup site.
I have a question. Did you have a hackathon? What is it all about?
Yeah, so hackathon, I'm not a fan of calling it the hackathon. It really means the advanced section. So we originally Sean had this notion that he would have this beginner section once a month, and that he would, what he called a hackathon, which was basically meant advanced users sitting around drinking beer and asking tough questions and solving tough problems and contributing. It's a little bit of contribution session. So that was good.
But we did. It was.
We canceled it.
Write code in some of those, and it was, we hacked it from time to time. But in terms of a full-fledged hackathon, we have done that here. They've gone on for 3 days, or we've done 1 day here, 1 day at Yahoo, 1 day somewhere else. So we'll make sure that we don't blur the terms. When it's on the same night as this, and it's only from 7 to 9, then it's probably not the 3-day version. But it's the advanced version, and it just sort of depends on who shows up. We always want to solve some problems and fix bugs during sessions, and depending on where it goes. So sometimes it does go there, but sometimes it doesn't, and it's just a discussion. Some of the discussion goes out into the parking lot. We're out there until 11 o'clock at night because we do need to clear out of here. But okay, get more.
Not really, but I'll be attending a hackathon. Developer Week hackathon is this weekend. $20, and you can come and hack on. In our session, we're doing Helium Development Platform. Please show up.
In San Francisco, yeah.
San Francisco at the Village 969 Market Street. But just go to developerweek.com, click on the hackathon thing, and come and join us. Thanks.
Not just us, the whole Bay Area.
Oh, yes, it's not just us.
It's not an HP thing.
There's other companies with 3 letters in their names and others that are all going to be there. There's like 20, there's like at least a dozen sponsors. We're one of the main sponsors.
Yeah.
Thank you very much.
Developer Week goes on always.
Yeah.
Thank you, Son. Thank you so much for all attention.
Everybody standing ovation for Solomon.
Standing ovation for Solomon. Standing ovation for Alina, who always appears on time to thank her. Who just put this on every single week. Thank you, and thank you for Chava.
Oh yeah, thank you, Chava. And standing ovation for Chava.
Yeah, standing for you, Chava. Thanks, everyone. Please help us clean up by just picking up your stuff.
Yeah.